Okay, today we're going to look at the topic rational exponents. It's section 12.4. And we're going to start off by reminding ourselves about one of the properties of exponents, which is this one here. A to the power of m times a to the power of n equals a to the power of m plus n. We remember that. Now, let's apply this to a situation where the exponent is a rational number, and we remember a rational number is a number which can be written as a fraction. So let's try x to the power of a half. Now if we multiply that by itself, x to the power of a half times x to the power of a half, following this rule that we've just reminded ourselves about, this one over here, following this rule here, we can say, well, that equals x to the power of a half plus a half, which is x to the power 1, or as we normally call it, x. Well, this is odd because we know that to get x by multiplying something by itself, that thing has to be the square root. We know that the square root of x times the square root of x equals x. And what that means is that x to the power of half equals equals the square root of x by definition. Okay? And this notation follows on. We can say that y to the power of 1/3 equals the cube root of y. Z to the power of 1/4 equals the fourth root of z, and so on. Okay? Now, these things can be combined, so let's look at a situation like this. Y to the power of a half cubed. Now, again, we need to remind ourselves of the rules of exponents, which applies here. This is the rule where a to the power of m to the power of n equals a to the power of m times n. So let's go back to our problem. Y to the power of a half cubed equals y to the power of 1/2 times 3, which is y to the power of 3 over 2. Okay? So it's a simple example. Let's look at another one. We'll look at the cube root of x squared. Well, the cube root of x, we know, can be written as x to the power of 1/3 squared. X to the power of 1/3 squared is x to the power of 2 over 3. Let's look at another example. Let's change colour. We can have the fifth root of the variable a to the power 4. That can be written as a to the power 1/5 power 4, and that is a to the power of 4 over 5. Okay, so this rule follows on in all examples. So we're going to start off on page 713, and we're going to look at questions 10 to 13. And there they are. Okay, we're now going to write some problems going in the other direction, where we're going to write take a problem which is written in rational exponents and convert it to radicals. So let's take an example, 5 to the power of 3 over 2. Well, 3 over 2, we can simplify that. That's 5 to the power of 1/2 times 3. 5 to the power of a half, that's the square root of 5 to the power 3. And there is our expression converted into radical form. Let's try another one. 6 to the power of 1/4 is 4th root of 6, etc. Okay? So let's continue. Same page, we're going to do questions 14 through 17. And there they are. Good. Right. work through these and pause, and we will come back to continue in a minute. Okay, what we're going to do now is we are going to evaluate these expressions. So let's take an example. 16 to the power of 3 over 2. The first thing we need to do is to split this up, split the rational exponent up into its component parts. So this is 16 to the power of a half times 3, which is a square root of 16 cubed. Now we can start to work out what this means. The square root of 16, we know what that is. So that's 4 to the power 3. 4 to the power 3, we can work that out. 4 times 4 times 4, that equals 64. So we can evaluate these exponents quite simply. Let's look at another example. Let's try 8 to the power of 4 over 3. We split up the exponent. Like so, 8 to the power of 1/3 to the power of 4, which is the cube root of 8 to the power of 4. The cube root of 8, what number multiplied by itself 3 times, something times something times something equals 8. Well, the answer there is 2. 2 to the power of 4 is 60. So there we go. So we'll continue down the page. Same problems, same page, new problems. We're now going to look at how these numbers with rational exponents multiply together. So let's look at an example. 5 to the power of 1/3 times 5 to the power of 2/3. We need to remind ourselves of the rule here. A to the power of m times a to the power of n equals a to the power of m plus n. So 5 to the power of 1/3 times 5 to the power of 2/3 equals 5 to the power of 3/3. 3/3 is 1. That's 5 to the power of 1. 5 to the power of 1 equals 5. Nice simple problem. Let's look at another one. 7 to the power of 1/3 to the power of 6. Again, let's remind ourselves of our rule. So this is a to the power of m to the power of n equals a to the power of m times n. And let's see how this works here. 7 to the power of 1/3 times 6. So that's 7 to the power of 6 over 3. 7 squared. 7 squared, we know what that is. That is 49. And then the last one we're going to look at is this rule here. 4 times 25 to the power of 1/2. Okay? So the rule that this one is following is a times b to the power of m equals a to the power of m times b to the power of m. Okay? So this would give us 4 to the power of 1/2 times 25 to the power of 1/2. 4 to the power of half, that's the square root of 4, which is 2. 25 to the power of 1/2, that's 25, the square root of 25, which is 5. And that gives us the answer, 10. Right. So the problems we're going to be looking at here are the next section down the page, on page 713. This is 30 through 38, which are below. And there they are. We just have one last section to complete, and that is replacing the numbers in our expressions with variables. So let's look at one of the examples they give us. X times y to the power of 1/2 squared times root x. And we really need, there's a number of things we need to do here. We need to distribute the powers and then combine them. We'll start off distributing the power in the first bracket. So that gives us x squared times y, and then the square root of x. Square root of x, we know how to write that. So that's x squared times y times x to the power of 1/2. And we then need to combine the x terms, and that's going to give us x to the power of 2 plus 1/2 times y. 2 plus 1/2, we can simplify that as x to the power of 5 over 2 times y. Let's try one more final example. Similar looking problem. Again, we start off by distributing the original power. And there we have our solution. Okay. So the section we're going to be looking at here is 39 through 44. And there it is. Now, once those are complete, please go on to the word problems on page 714. Question 46. There is an explanation of how to do this in the lead up to the question, the example, volume of a sphere. Please read through that, try and work through that, and then complete the problem. Okay, that's it.